Viewers and subscribers.
Hello, viewers and subscribers. My name is Ramon Green. I'm a certified electrician, high school teacher, and I just want to welcome you to my YouTube channel.
Welcome back to my YouTube channel, Green's Electrical School, where knowledge is our expectation. Right? So yes, we expect you to get knowledge once you become a part of this YouTube channel. Please remember to hit that subscribe button and hit the notification bell so that you can be notified whenever we post our next exciting video like this. Right? So um, this today we want to learn about parallel circuits. This video is mostly geared towards persons who are in the field of electrical technology, or studying it at high school, or studying at university or college, wherever. You want to brush back to the fundamentals of calculating parallel circuit. So somebody posted a question and asked me a question to do a parallel circuit calculation, and we'll be doing just that right here on this YouTube channel. You understand? So please pay attention and let's try to dig into some learning. Okay? So we want to get to the question. I have the question written out on this little board I have here. Right? The question is this. Somebody want to find out. It says calculate the total resistance in a parallel circuit of 3 resistors, each having a resistance of 5 ohms. And it also goes further to say calculate also the total current and the total power within the parallel circuit. Now the question is, many may asking, to understand this question we have to know what is a parallel circuit. Now I've written a little, definition. It says a parallel circuit is a circuit with more than one path for electricity to flow. Okay, so that is versus a series circuit that only has one path for the electricity to flow, meaning it flows from load to load, and the circuits are not connected independently. Whilst the parallel circuit, the circuit or the load, it is connected independently, right? So we want to get to the question, right? I want to dissect the question so that we can properly understand what this circuit is. Yes. So we want to calculate the resistance according to the question. So it says calculate, and yes, calculate. Electricity does have some calculations in it, and it is based upon mathematics. It's not only to wire a building, or learn about appliances and doing the work itself, but it also going to the books and the drafting board and doing some nice calculations, right? So it says calculate the total resistance. So we have to interpret the question. We know that we have to calculate the total resistance in a parallel circuit, and I have to point that out because whenever you ask to calculate, you have to know what kind of circuit you're dealing with, so that you can know what rules apply, because the rules that apply in a parallel circuit is not the same rules that apply in a series circuit, right? So it says in a parallel circuit of 3 resistors. So now we know that 3 resistors are connected in parallel, each having a resistance of 5 ohms. Now, ohms is a unit we use to measure resistance. Just like how you use centimeters or meters to measure length or height, we use the unit ohms. The symbol for ohms is this. It's like a horseshoe, it goes up like that, and it likes that. But this is how it's written in words. But this is a symbol, ohms, right? We use it to measure resistance. Okay. All right. So for now, we're gonna skip worrying about the current, total current, and the total power. All right. Shoot, there's something that was missing from this question as well. The voltage that was given in this circuit was 10 volts, right? So the voltage was also given. I forgot to write it. The voltage, right, was 10 volts. It was given in the question as well. Okay. Okay, so we're going to calculate the resistance first because they say calculate the total resistance. So the first thing I want to do is to draw the circuit. Okay, so we're going to get our camera zoom in nicely on the circuit itself. Now, ladies and gentlemen and viewers and subscribers, this is a parallel circuit, right? According to the question we have received, this is the drawing of this parallel circuit. So we have 3 resistors, okay? Right? 1, 2, 3. And this is the symbol we use for resistors. It is a rectangular box, right? Like this. And I want to draw this out because there's something I want to point out to you, viewers and subscribers, so you don't get confused. Right? It's a rectangular box like that, having 2 leads. Right? The 2 leads represent either the positive end or the negative end, whichever. All right. Now, our next symbol within electricity field is this. It looks quite similar, and you have to pay attention because you don't want to get both of them confused. All right. The next symbol is that. Now, this symbol, they look similar, but this symbol down below represents a fuse, not a resistor. Whenever you see the line is drawn right through the rectangular box like that, it means it is a fuse, not a resistor. Okay? So I just want to point that out so you don't get yourself confused. Okay? Right. So we have the resistor symbol, and this is what we use to draw and plug them into a circuit. Our next symbol we use for resistor is this symbol right here. You draw a line like that and you give some zigzag ends to it. You don't want to make the zigzag ends too smooth because it can mean something else, which we'll talk about in the next video. So it's a zigzag like a zipper up and down, and they represent the resistor, right? But for today we'll use the rectangular, which is more, to me it's more decent to be used, and it's less confusing. Right? So we plug them in. Each, as I said before, each end is either positive or negative. So in this case, I've drawn the circuit, and the red end represent the positive end, and the blue end represent the negative end for the resistor. And I have plugged them in independently, meaning because it is a parallel circuit, then each resistor or each load would have been connected to the positive and the negative side of the circuit independently. So it doesn't depend on the connection of this resistor for this resistor to work. Now this resistor does not depend on the connection of this resistor for this resistor to work. They are all connected independently, and we're going to see that when we look at the flow of electricity in this circuit right here. Bear in mind, if you're missing a step with me, viewers and subscribers, please pause and rewind and to try to catch on what I'm really saying, because many times you won't comprehend what I'm really saying in the first instance of watching this video. Okay, so the current flow or the flow of electricity, and we have discussed about electricity in a previous video, it is flowing from the positive end of the circuit. Okay, so as you can see, it goes to this resistor here, which we label as resistor 1, as R1 right here. We label it R1 because it is a resistor that is more closer to the source, right? So the current the electricity gonna come here first, then it goes on to R2, which we label as R2 here, which means resistor 2, and it goes to R3, which is resistor 3, right? So the current flows to all 3 of them, but some is more closer to the source than some, right? So hence we label them like this. Okay, so as the question said, each of them is 5 ohms, viewers and subscribers. So we're gonna get to the calculations right away, and we want to deal with the total resistance. So all right, here we go. RT, and we're gonna call the resistance total for short RT. This means resistance total would have been equal to. There are 3 formulas in calculating resistance, viewers and subscribers. There is more, but whenever we come to parallel circuit, we use 3 basic formulas. This one I'm using is a more longer one, but it's a general formula, meaning it can be used to calculate any parallel circuit. But the more shorter ones can only calculate specific type of parallel circuit, and I want to show you those afterwards. So I'm just showing you the general formula we use to calculate resistance in parallel. So here we go. The formula is this: we will have 1 as a fraction there over another fraction over R1. So we call this the 1 over 1 method, okay? So plus 1 over R2, which is resistor 2, plus 1 over R3. So here we go now. We are going to, what we're going to do to make this more simple, we're going to forget about this fraction here for now. And we're going to say it is equal to, we're going to plug in our values for these. We already know that all of them is 5 ohms according to the question. All right, so here we go. It is equal to 1 over 5 ohms, right? Plus 1 over 5 ohms again, plus 1 over 5 ohms, because all of them are rated at 5 ohms. So here we go. What we're going to do is to divide the 1 by the 5 for all of them, right? All of them. So when you do that on your calculator, you will be receiving this value here, 0.2 plus 0.2, because it is 5 again, 0.2 plus 0.2 again. All right, so now we are gonna add these together. We're gonna add these together, and you're gonna get a value of 0.6. all right, forget about the ohms for now. We just want to make this thing more simple, okay? So 0.6. So what we do here is we're gonna draw what now for this value here. Remember we moved it from the calculations earlier. Now we're gonna bring him back. So we're gonna say, all right, is equal to 1, this fraction here, over 0.6. And what we're gonna do is to calculate this value, and it should give you the value of the total resistance in the circuit. So we're gonna put a symbol and say, therefore, this triangle, this 3 dots, the triangular 3 dots here means therefore RT, the resistance total, is equal, right? Is equal to when you do this calculation, you will end up with a value of 1.666. You're gonna see a lot of sixes, but we can round that off and say, all right, it is 1.7 ohms, right? Or if you want to get rid of the decimal, you can say it is 2 ohms. All right, so that's how we would have calculated the total resistance in the circuit. And what we're gonna do up here, we're just gonna plug this value in to our circuit here. So we can say RT, right, is equal to 2 ohms. And we're just gonna do it because we already have 10 volts as a total voltage. So we don't want to work with too much of the decimals. So we want to get rid of the decimals, so we can just say equal to 2 ohms. Okay, so we have plugged in our resistance total value, right? So it is equal to 2 ohms for simplicity. Okay, so you can use this formula, viewers and subscribers, it's a general formula to find any resistance in a parallel circuit, right? To find the total resistance in a parallel circuit. So you wouldn't have to worry about the others too much, right? I'll be posting the next video on the others so you can understand how to use them and stuff, but we don't want to take up too much of the time in this one video. So the next section of this calculation, it have asked us to find the total current. So there's not space